Hi, I've got a bunch of examples of altitude on hypotenuse problems here, and I'd like you to try these first. I'm really using this as kind of a bell ringer or opener activity. And the big thing is I want to make sure you've got all the different patterns down, and I've tossed in at least one, maybe two that go a little bit beyond what we discussed in class the other day. So this will cover most of the pretty typical scenarios that you can see. So I'd like you to take the next 5 minutes or so and try these four problems. By the way, you'll notice that I've turned these different ways. For some people, that doesn't really bother them at all. Other people like to have problems turned exactly the same way every time. So if you're somebody who likes to see it exactly the same way, and that's the only way that you can visualize the pattern, draw them in a different position. But anyway, I'm going to pause the video here, or rather, I'm going to ask you to pause the video. Take 5 minutes, see if you can work these out, and then you can check your solutions. And of course, you don't need to watch every single part of every single problem if you think you did the problem right, but definitely go to the ones that you think you need to see. So I'm going to pause briefly. You need to stop the video though, and then I will come back and go through the solutions. All right, I'm going to talk about solutions, so if you haven't tried these yet, try them first. Stall the video. All right. Okay, the top left one is the first one I'm going to look at here. And I think this one's pretty straightforward. Remember that the altitude is the geometric mean between the two parts of the hypotenuse. Okay, so remember the geometric mean is your repeated value on one diagonal. Now, the interesting thing here, of course, is that they give us the altitude. So that is going to be the repeated value in our diagram here. So when we set this up, we're going to have a 2 radical 10 in the altitude positions on that one diagonal. And then we do have the two parts of the hypotenuse. We've got a 4 and we've got an x, and we can cross multiply here. Be careful. When I multiply 2 radical 10 times 2 radical 10, I would think 2 times 2 is 4, radical 10 times radical 10 is 10, 4 times 10 is 40. If you're going to put that in a calculator, make sure that the whole thing is getting squared, okay? If you don't put that in parentheses, you're going to end up just squaring the radical 10 and not the 2, and you'll end up with an answer of 20 instead of 40. So anyway, if you cross multiply here, multiply these together, and we're going to get an answer of 40. And then that's going to be equal to the cross product going the other way, which of course is going to be 4x. And that means that x is going to end up equaling 10. All right, so there is our first problem. Hopefully not too bad. A little bit of a twist compared to the basic pattern, but pretty close to the base pattern. All right, let's take a look at the second one now. I am extremely visual, probably why I teach geometry. I need to see these in a certain position for the pattern to click for me for whatever reason. So I'm going to flip this guy over and do something kind of like this on number 2. All right, on number 2, so we've got a 4 here, and we've got a 32, and we've got a y. Okay, this is the leg pattern. Okay, the leg is the geometric mean between the part of the hypotenuse adjacent to the leg and the entire hypotenuse. Okay, maybe you could call that like part 1 and a hypotenuse or something like that. Anyway, I kind of think of the pattern visually, but that would be the basic setup. So this time we are solving for the leg. So that y value is going to go in on the diagonal. Got a y there and a y there. We have the part of the hypotenuse adjacent to the leg, that's 4, and be careful, the entire hypotenuse is going to be 36, okay? If you cross multiply there, you're going to end up finding, I'm running out of room here, but you're going to end up finding out that y squared is equal to 144 when you multiply that out. And of course, the square root of 144 is plus or minus 12, but of course, this is geometry, so we just want the positive length there of 12, so I'll write that in. All right, we move on to number 3, and I am going to scoot my face a little bit or we're not going to be able to see those. All right, Number 3 is pretty much set up the way I normally do these. Notice that we have a lag involved and not the altitude, so we're going to be dealing with the lag pattern again. When we set this up, remember that the lag is the geometric mean between the adjacent part of the hypotenuse and the whole hypotenuse. Okay, you do need to be careful here though, because the whole hypotenuse wasn't given to us. Okay, I don't want to put an extra variable in here. I mean, I guess if you wanted to call the entire hypotenuse y and then you wanted to figure out what x would have to be, I guess you could do that. But just label the entire thing, okay? You would add those two parts together, and that whole length there is going to be x plus 4, okay? So that's going to be the entire hypotenuse. And so we just fill everything in. So the lag is the geometric mean. That means the lag is your repeated value, which is why I call it the lag pattern. Altitude pattern, you repeat the altitude. It's the geometric mean between the adjacent part of the hypotenuse and the whole hypotenuse. And then we just have to cross multiply and solve here. You're going to get 196 is equal to 4x plus, be careful, make sure that both the x and the 4 are getting multiplied by 4. It's going to be 4x plus 16. If you subtract 16 from both sides, you're going to get 180 is equal to 4x. Let's see, half of 180 is 90. Half of 90 is 45, so x is going to equal 45. And I think if you check that, that would give you a whole length here of 49 along that hypotenuse. And I didn't know it off the top of my head, but 4 times 49 is in fact 196, so the numbers work out pretty nicely. All right, we have 3 down. We have 1 left to go. I'm guessing that this last one might be the one that some people might have had some trouble with, because you have to remember Algebra 1 to be able to do it. And I'm hoping it's Algebra 1 that came up a decent amount last year in geometry. Again, I like these turned a certain way. So I am going to redraw this. And that's not the best drawing. There we go. Okay. And we have a 4 on a leg here, and we have an x next to it, and we have a 6 next to that. Okay. So once again, it's a leg pattern. I have 3 leg patterns here because I think the leg pattern is a little bit more challenging. And so remember that the leg is the geometric mean. So we can fill that in. 4 is going to go on one diagonal between the adjacent part of the hypotenuse and the whole. Okay, that's going to be an x, and that whole hypotenuse is going to be x plus 6. Okay, make sure you're adding those two things together. So that's what we're going to have. And if you cross multiply here, things get a little bit interesting from an algebra standpoint. All right, so let's look at what's going on there. All right, so clear myself some space here. All right, so if you cross multiply here, you're going to get, of course, 4 times 4 is 16. No big surprises there. And if you cross multiply going the other way, x is going to get multiplied by x, which is going to give you an x squared. And then 6 times x is going to give you a 6x. Okay, so this is a quadratic. Of course, one of the big topics from Algebra 1, one of the more advanced topics from Algebra 1. Hopefully something you saw occasionally in geometry, but it's not always a focus of geometry. So a couple things about quadratics. Remember, all of the solving patterns used for quadratics are kind of special. You can't just add and subtract and multiply and divide. You're going to have to use the quadratic formula, or you're going to have to factor, those types of things. You also want your equation equal to 0. So I'm going to subtract 16 from both sides. I've got x squared plus 6x minus 16. Okay, quadratic formula is probably the most standard way to do it. If you haven't thought about it for a while, x equals negative b plus or minus the square root, b squared minus 4ac. All of that should be under the radical. All over 2a. Okay, hopefully you have that memorized. If you don't, put it in notes and get it memorized. We expect you to know that all the time. Okay, remember your a, b, and c values are your coefficients in your quadratic. So a is 1 x squared, b is going to be 6 in front of the x, and c is going to be negative 16. All right, so if we fill everything into the formula here, the opposite of b is going to be negative 6. plus or minus the square root of b squared. 6 squared is going to be 36, minus 4 times a, which is 1, times c, which is negative 16, okay, all over 2 times a, which is just going to be 2. Okay, be careful here under the radical. You've got a negative being multiplied by another negative, so that's going to give you a positive 64. Okay, and we're going to end up with, and I'm running out of space here just a little bit. I'll go up top here. We end up, when we simplify this, with negative 6 plus or minus the square root. 36 plus 64 is what you're going to have down here when you multiply out those two negatives. 36 plus 64 is 100. Okay, and then you're going to be dividing that by 2. Okay, so anyway, need a little bit more space here still. We can do that. All right, so negative 6 plus or minus the square root of 100, of course, is 10 divided by 2. So remember, you're going to have two answers for most quadratics. So negative 6 plus 10 is 4. 4 divided by 2 is 2. Negative 6 minus 10 is negative 16. Negative 16 divided by 2 is negative 8. Okay, x is a length in a diagram. Okay, negative 8 doesn't make any sense here. So 2 is going to be your final answer. Okay, so there's the quadratic formula. Honestly, that's not the fastest way to do that. The fastest way to do this would have been to factor. And I would highly encourage you to think about factoring on this particular problem. And so if we go back to that, oh my, I've forgotten what the equation was. Let's see. I think it was x squared. Did I write this down? Oh, I did. Plus 6x minus 16 is equal to 0. And remember, when you factor, you're basically just going backwards to the FOIL problem that was originally set up to get x squared plus 6x minus 16. So you have what are called two binomials, two positions in each set of parentheses. And basically, you just have to kind of common sense your way through what would you fill in here to multiply out to get this if you think backwards through the FOIL process. So, of course, the first position is going to multiply by the first position, and that should give you x squared. So it would make sense to have an x and an x in those first two positions. When I think about FOIL, first, outer, inner, last, I always jump to the last step of FOIL. The constant number here needs to multiply by the constant number over here to give me that negative 16. Okay, so I need two numbers that are going to multiply to be negative 16. All right, the two middle steps, the outer values, x is going to be multiplied by that blank there. The inner value, that blank, is going to be multiplied by that x. Both of those terms are going to have an x. Okay, so those two terms are going to add together to give me that 6x term there. So I really need two things that multiply to be negative 16, and I need two things that are going to add to be positive 6. Okay, so 8 and 6 will do that. We're going to need to make the 8 positive, and we're going to need, 8 and 2 will do that. And we're going to need to make the 2 negative. Okay, that's not an answer. Okay, that's not an answer of 8 and negative 2. Okay, because if you remember from the quadratic formula, that's not the answer. What this is saying is this times this is going to give me 0. Okay, if you remember the zero product property from Algebra 1, anytime two things multiply to be 0, you have to have your equation equal 0 for this to work. But anytime you have two things multiplying to equal 0, and we have x plus 8 being multiplied by x minus 2 to give us 0. Anytime two things have a product of 0, one of the two values has to be 0. Okay, so either the x plus 8 has to be 0, or the x minus 2 has to be 0. Okay, well, if you think about it, negative 8 would make that top equation 0. Of course, negative 8 doesn't make any sense as the length of a side of a triangle, so that's not going to work. 2 minus 2 would be equal to 0, and that is our other solution. Okay, that's our positive value that is going to fill in that missing value. So again, 95% of the time, especially prior to pre-cal, you're going to be able to do these problems, these quadratics, a lot more easily if you factor. But if you can't get it to factor, the quadratic formula is always a way to guarantee doing it and getting a correct answer. So anyway, hopefully you did pretty well on those. Hopefully you learned something or reviewed a couple of algebra concepts in that last example.